Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to this Godot tutorial / code along series. This is a beginner series for people who are at least somewhat familiar with programming, but absolute beginners to Godot. And I expect this series to last about 4 to 5 videos, and I'll be making those videos over the course of the next week or potentially 2 weeks, depending on how my schedule goes. We're going to be using the Kenny Pixel Platformer assets, so this will be a pixel art platformer game. And just want to give a huge shout out to Kenny and their wonderful assets. You can check out their website at kennyey.nl, and yeah, they've got tons of great assets on here, a lot of them public domain. Great stuff. So you'll click the download button here, and that should download them onto your computer. I've already downloaded them and extracted out the files. So we're inside of Kenny Pixel Platformer, and we can go into the tile map folder right here. Now we're going to be using this characters packed and tiles packed tile maps here. So let's minimize this and open up Godot. Now Godot is a open source, completely free game engine. You can download it at godotengine.org. And we're going to, yours won't have these other projects here. These are projects that I've made, and we're going to just click new project here. Now we need to select a folder. I have in my documents, I have a Godot 3 folder. I'm just going to open that and then hit select current folder. And we're going to call this Pixel Platformer. And we'll do create folder and create and edit, and that will create the project for us and open it up inside of the Godot editor. Now we need to come open up our file system here, and we can, well, actually, let's pause for just a second. So currently, if we click on this icon here, double click on it, you can see that there is a filter being applied to this texture. It's kind of blurred. And so since we're making a pixel art game, we don't want that. And the way that we can fix this is by coming into import, selecting preset, selecting 2D pixel, and then with our icon selected, selecting re-import. And now you can see it removes that blur that was there. Now this is kind of a blurry icon just by nature, because it's not actually pixel art, it's just really low resolution. But now you can see each individual pixel is nice and crisp on it. And so we've correctly imported that. Now we can click presets again and do set as default for texture. That way every single texture that we import into our project will now have the 2D pixel preset the way it is imported, so it will all be imported as crisp pixel art. Now we can come into here, select characters packed, and select tiles. I'm going to hold control, select tiles packed, and drag these in over here to our file system. As we select those, you can see that they're nice and crisp. The pixel art looks really great. So now in Godot, we need to create a new scene, and this scene is going to be a level that the character will be able to move around in, and we want it to be a 2D scene. Godot is both a 2D and a 3D engine. So I selected this 2D up here, but we can also just click 2D here, and this will add a node to our very first scene that is unsaved. And this node is just a node 2D, which means really these are its properties here, but the main thing that it has is it's got a position, a scale, and stuff like that. So we'll call this world, and we'll hit Control S to save this scene and just save it. And now we can click run the game. And it needs us to select a scene that is run every single time the game is run. So that's kind of the first scene that is run. And we'll just select current, and that will select our world. Now you can see that we're running the game here. Now if we drag over, if we click on our textures, we drag over tiles packed and run the scene, or just run the game, I guess. You can see that we can see those tiles here. And that's because when we drag over this texture, it creates a sprite node to display that texture automatically. Godot automatically creates a new node and it assigns the texture to this slot here. But the problem is our resolution is really bad for a pixel art game. Like, this is pretty tiny. We want to scale up that pixel art. And so in order to do that, we can go into projects, project settings, and let's see where it's under. Sometimes I can find it right away and sometimes it takes me forever to find it. Okay, it's under display and window. Now we can set the window size here to 320 by 180. And this will give us a much better window size. You can see here, you can actually see the window size if I hide this. And if we run the game, didn't work, right? It set the window size, but we're not actually scaling up this window. So how do we scale up the window? We come into project settings, and then we set the test width and test height. So this is kind of like, the first settings are the kind of like view in the game, and then the test width and test height are the scale of the window on your screen. So we're going to do this 1280 by 720, which is scaling our pixel art by 4. Now we also need to select its stretch mode. Currently it's disabled. We'll want to set this to 2D. Okay, now when we run the game, boom, there's our pixel art right there on the screen, nice and big. Okay, so we've got our window set up properly. We've got our pixel art set up properly, importing properly. We can delete this sprite here. And we're going to create 2 other scenes. Now, Godot uses scenes and it uses nodes. And nodes are kind of like the tools, and scenes are kind of like the tool boxes. And so a scene is a collection of nodes, and there are certain tools that are useful together. So let's say we have a player scene, and the player is kind of like the toolbox, right? But inside of that player scene, it needs to have certain things that it can do. It needs to be able to show a sprite. It needs to be able to handle collisions. And those different things can be handled by nodes or tools that are inside of that toolbox. So first we're going to start off by making a new scene, clicking the button up here, a new 2D, well, no, we're not going to do 2D scene. We're actually going to do other node, and we're going to do static body. Now, a static body is a collision or physics node that can handle collisions, and they're generally meant for platforms because they're static. They're meant to kind of stay put in the world, and think of it as like a rock or a brick or something that the character can run into. We're actually going to just call this one block. Okay, and we're getting a warning message here. This just tells us that our static body doesn't have a collision shape node. So we need to click this little plus button. So when it's selected, click the little plus button and search for collision. And we're going to do a collision shape 2D. We can select this collision shape 2D, but it still needs an actual shape. This is just the node, but we need a shape that defines what that node looks like. So we're going to come over here, click on shape, click on empty. Here we get a rectangle shape, and we can create, it automatically creates a rectangle shape. Now we're going to turn on use grid snap, this little button here, and we're going to drag the corners of our shape to that grid snap, and then I'm gonna hit Control S so we can save our block here. Okay, so we've got a block scene. It's got a collision shape, but there's no way to see it. So we're going to add a sprite to this. And we're actually going to use an animated sprite, even though it won't be animated. Funnily enough, well, you know, let's actually, I'm gonna let's delete it. Let's use an actual sprite. We'll use an animated sprite for the player. So we'll just use a sprite here. Now the sprite node needs a texture. So we can come over to our tiles packed, drag it in here to texture, and that gives us, we can see every single tile now all at once, right? Because we drag over the entire tile map texture. in order to select a specific section in this, we need to click on region over here when our sprite node is selected, and then click enable. Okay, now we can't see anything except this tiny little piece here, which doesn't even show anything. So we need to click on texture region down here. This will show us the texture. We can pan and zoom here. This will show us the texture, and we can select a specific region. Okay, and there's a lot of things here that could make a good brick. Probably this one is the one I'm going to choose. So we can kind of zoom in on this a little bit. We want to turn on snap mode, and for this we can just do pixel snap. I think that should work just fine. And we can click with our mouse and select and drag until we've selected this brick exactly. And now you can see that it is displayed. That's the only region inside of the texture that we are displaying for this sprite. So we can click texture region again to get rid of that. And now we can click on our, we'll actually click on the sprite node and drag it up so that it's displayed behind our collision shape. Now we can click on the collision shape and increase, our snap is not correct. So let's click on these three dots, configure snap. It's currently set to 8 by 8, but this Kenny asset is actually set up to be 10 pixels by 10 pixels. So we'll do 10 by 10. Okay. I lied. It's 9 by 9. Really? That surprises me. Okay. But let's do... Oh my gosh, I can't click that. 9 by 9. Okay. There we go. Now we can drag out our collision shape so that it lines up perfectly with our block. And if we come into our world, we're also going to want to set collisions here, and we're going to want to use the same 9 by 9. So configure snap, and then we'll do 9 by 9. Now we can drag this brick into this world, or this block. Wait. I see, it's 18 by 18. That's what it is. But 9 by 9 works for this, for what we're doing here. And if we run the game, we will see our brick displayed in the world very nicely. And let's move it over here. Now, if we want, we can duplicate this brick by selecting the block here and doing Control D. Did I have you drag it in from here? I think I did. You can also create it using this button. So you can select this and then click block. Okay, so we duplicated this one. Now let's drag that over here. And I'm going to just make a few blocks. Just like that. Duplicating them, we got them over here. We've got a lot of blocks there together. Looks good, actually. Looks really good. Kenny did a good job with the pixel art. Okay, now we're going to create a new scene, and this is going to be other node, and we're going to use a kinematic body. Now, kinematic body is a different type of physics body, where we had static before. Static is meant to be like bricks, rocks. Kinematic bodies are meant to be like player characters. Specifically player characters where you want to have a lot of control over how they move around in the world, and specific control like their acceleration and gravity. You're going to control all those variables. So great for platformers. We're going to click on this. We're going to do player. Now it needs a collision shape too. So we'll do collision shape 2D. We'll just do a little rectangle again. And we're going to need a sprite that's attached to this. So we'll do an animated sprite this time. This will allow us to animate our character. Now animated sprites, they need frames, not a texture. And the frames resource will have textures inside of it. So we'll click on frames, new sprite frames. And usually it opens up a tab when you do that, but it didn't this time. But I bet if I click on this, Yep, so I just clicked on frames and it opened it up. You can see this new sprite frames tab. We need an animation here. I'm gonna double click on this and we'll name this idle. And all we need to do is select, now we need to add some frames to our animation. So we can select this and we can select characters packed, open. Now we need to tell it how many frames there are horizontally and vertically, and it's 9:3, not 34, 3. Okay. We can zoom in with control. And we need to select the frame that we're going to use. Now you can pick any of these characters you want. I'm going to pick the little green guy, the default green guy, and just have the normal standing, not with his legs separated, and do add frame. Now we've got our idle frame for our character like this. Looks great. I'm going to come into I'm going to click on our animated sprite, and I'm going to click on flip horizontal so he's facing to the right. Then I'm going to move our sprite up above our collision shape again, and we're going to set the collision shape for our little character. Now we can turn off snap, and we should be able to have pixel art snap. Now if you don't have pixel art or pixel snap set, click the 3 dots and just make sure that use pixel snap is checked. Now we can set I'm going to set the collision shape for our little character to be about like this. You generally want to have their collision shape to match up pretty nicely with the feet. And I think this will work pretty well for our character. We can hit Control S to save. Now we have a player character, and if we come back into our world, we can select the world node, the root node, and we can drag our player scene into the world. I'm going to turn off snap. We should have pixel art snap on and drag it up until it's just standing right here on that little block. And I'll turn snap back on and run the game. And there's our character standing right there on the blocks. However, he doesn't have gravity applied for sure. If we put him up here higher and run the game, he just floats there in the air, so we don't have any gravity. This is where we're going to, we've kind of got through the setup, right? We're 17 minutes in, we've gone through the setup. But this is where the fun part starts. I mean, the other parts are kind of fun too. Setting up this nice pixel art in the world. And so now we get to attach a script to our character. So we'll click on the player scene, then the player root node, and then attach a script. And Godot will automatically make it inherit from a Kinematic Body 2D, and it will give it a player.gd name. So it copies the name of the scene or the root node of the scene. So we'll create it. Now we've got our first script open, and you can see at the top here we can switch between 2D and script. Okay, and we can drag this over and click output to get rid of that. And we can give our we can do some stuff with our character. Now in Godot, the ready function is called right when a scene, kind of like when a scene is first created. So right when the player scene is first created in the world. So it'll happen right when it's created, right when we run the game, or right when that level starts. And so we can do anything we want in here. We can, if we want to, we can just say print. Oh, good. If I can type print, hello world, the classic, right? And if we run our game, you'll see that because our scene has a player scene, and right when it's ready inside of this world scene, it prints hello world down here. So what do we want to do? We want to add some gravity. So we're going to create a variable first. We're going to call this velocity, and we're going to set it equal to vector 2.0, like this. So that's going to be a 0 vector, which means our velocity will be 0 and won't have any sort of a direction to it. Okay? Now we're going to add a new function. Now this function is called the physics process. And this function is called every single physics frame of the game. Now, by default, Godot has the physics to update 60 frames per second. I'm trying to remember where that is displayed in here. Physics, 2D, no common. Here we go. Physics FPS is 60 frames per second. So if we go into the project settings, by default, we're 60. So that means delta here is going to be 1/60th of a second. And I don't remember exactly what that value is, but that's how long it's been since the last physics frame. And since Godot caps it is 60 frames per second for physics, not for the game can run at much higher frame rates. It just only figures out the physics every 60 frames per second. This should always be pretty much the same value. Unless you have a computer that's really lagging, but for a pixel art game like this, it's unlikely to happen. Okay, inside of the physics frame, we can apply some gravity to our velocity. So we can say velocity dot y plus equals 2, right? And so that will, let's get rid of our ready. We don't need that anymore for now. We can save. That will apply to our velocity.y, which would be downward, every single frame, every single physics frame, or 60 times per second. And it's doing that. If we were to print our velocity, it would be a really high number right now. But our character still isn't moving. For that, what we need to do is call a special function inside of the Kinematic Body 2D. And if you hold Control and click on Kinematic Body 2D, it will actually open it up inside of the documentation. And in the documentation, we can see all of the methods and properties of a kinematic body. And if we look at methods, there are these 3 methods called move and collide, move and slide with snap. And these methods are used to move your character. Now, I usually use move and slide. So what we can do here is we can say velocity. Well, let's just do move and slide, and then pass in our velocity. There we go. So now that we have, now that we're calling move and slide, this function will automatically move our character and detect any collisions and then handle those collisions appropriately. If we run the game, you can see we fall down and we land right on our bricks there, right on our blocks. Now, move and slide also, what it does is it returns a vector too. That means once it's done computing, it spits back out something. And what it spits back out is how much velocity was left over after the collision. So like, let's say you land on the ground, your vertical velocity should be 0 now because there's no more velocity left over after the collision. So I like to set our velocity equal to move and slide velocity. So what that does is it computes it, and then it says what's left over after calculating the collisions, make that our new velocity. Okay? And I can show you an example later of why that's important. We've got our character falling. Now we can actually move our character too. So let's do if input dot is action, not just pressed, but pressed. Okay. If input dot is action pressed, UI right, velocity dot x equals 10. Let's try. If input dot, actually let's do elif, which means else if input dot is action just pressed, UI left, velocity dot x equals -10. Okay, so if we're pressing to the right, velocity.x equals 10, move to the right. Otherwise, velocity.x equals -10, move to the left. Else, finally, if we're not pressing either of these things, velocity.x equals 0. So that will stop us. And if we run the game, you can see we can now move to the right and apparently not to the left. Apparently we can't move to the left. Oh, it's because I did action just pressed. I told you not to do it and then I did it. Okay, there we go. Now we can move to the right and to the left very slowly, mind you. So let's set these to something like 50. Now some of you might be going, but Ben, you're supposed to apply delta. And technically you would be correct, and we'll probably discuss that in later videos. But since delta is going to be the same value because it's locked to this physics process of 60 frames per second, it's really not quite as important, and we're just going to leave it for now. Okay. Okay, looks good. We can move left and right. Now let's add jumping. This will be the last thing we do in this video because we're 26 minutes in. If input.is action just pressed, okay, UI up. So this time we only want to do it when you've just pressed the button, not when you're holding it down. We'll say velocity dot y equals -200. Run the game. Whoa, that's really high. I didn't think it would be that high, but I guess our gravity is really low. So let's actually leave it at 200. Just make our gravity a little bit faster because we're kind of floaty already. Here we go. Look at that. We've got a working platformer. I'm going to set this to 100. Okay, so let me give you an example before we end the video. Let me give you an example of what I mean when I say the leftover velocity. Watch this. I'm going to take off this, okay? We're going to put it back to how it was. Now, we're going to jump and land on this, right? So what do you think is going to happen when we walk off of this block? You'd expect us to slowly fall down, right? Nope. See how fast we fell? That's because our velocity.y is a crazy amount right now because it just keeps adding the gravity to it. And so when we collide with the ground, like say we jump here and collide with the ground, it doesn't actually reset our velocity. So our velocity is just crazy high. And so when we walk down, boom, we have to deal with that. But when we're colliding with the ground, if we set our velocity equal to what's left over after this, then it says, oh, you're colliding with the ground. There's no longer leftover velocity. Your velocity in the y direction should be 0 because you're colliding with the ground. The leftover is 0. And now you can see we do what you would expect, which is to walk off and then fall down. So that's the difference. And that's why it's important. And our jump is a little too low, I think. Okay, but we've got a working platformer with some nice, lovely 2D pixel art. And in the next video, we're probably going to start working with our code a bit to refine it and make our platform character feel better. Allow for a variable jump height and a little bit of friction and a little bit of acceleration to our character. So thank you so much for watching this video. I hope you found it helpful. I'm also doing a sale on my 1-bit Godot course, which it's been updated for Godot 3.4, and I'm planning on doing an update for Godot 3.5, which you will receive for free as well. So I'm doing a summer sale. It's currently $125 off. So I'm currently doing a sale. There'll be a link in the description if you want to check that out. It's 17 or 18 hours of content for learning how to use Godot. It's kind of the basics of the engine, the fundamentals of the engine. So you can check out that cell. There'll be a link at the end of this video. Thank you all so much for watching, and I will see you all in the next video.